Hey, good morning.
Morning! Great to hear your voice. What's something that's been on your mind lately?
So you have to act as an interviewer like AI or ML or also Python. So you have to ask me the questions and I will try to answer. Basically, I just want to revise my concept. That's why I am going to discuss with you these topics.
Absolutely, let's do it. We can jump right in. How about we start with Python? Why don't you tell me one of the key features in Python that you find really useful?
Okay, so it has a uh, very we can say simple syntax it contains, and that thing I like about Python.
Yeah, absolutely. Python's simple syntax is one of its greatest strengths. It really does make it a lot more readable and a bit easier to jump in and get started. Now let's switch gears a little bit. When it comes to machine learning, what do you think is one of the most important steps in a machine learning project?
Most important step is if you have any document or file, then we have to first read it. First we have to read it by pandas. I think that's the most important thing. That's the most important thing before applying any ML model. So we have to always go with the EDA, and I think this is the most important thing in the machine learning.
Yeah, you're spot on. EDA or exploratory data analysis is key. You have to dive into the data and get a feel for it before you even think about building a model. All right, next question. Are there any specific Python libraries you prefer when you're doing your EDA?
Yeah, I prefer lots of libraries of the Python when I am going with the EDA. So my favorite libraries and like of course all every people use these libraries in EDA. That is Python libraries. These are we have a Matplotlib and Seaborn, NumPy, Pandas, and also Sklearn.
Absolutely. Those are all the heavy hitters in the Python EDA toolkit. Pandas, Matplotlib, Seaborn, they all make it easy to explore and visualize your data. All right, let's keep going. Do you have any machine learning models that you tend to use more often, or maybe one that you find especially interesting?
Yeah, I always go with the random forest because it is like best for the overfitting and also good at accuracy, and it has a it's a example of the bagging where we take random uh, data, and we always take random data and feed to the model, and every tree has a different shape. That's so that they can take a different decision, and at the end they basically we go with the majority decision. So that's why I like random forest, but sometimes I also go with the XGBoost where we have a weak learners, and we basically tell to the another model every time that I have done some mistake in the confusion matrix. So you have to remember when you are going to predict. So I always go with these more algorithms like random forest and XGBoost. After XGBoost, I also use cross validation for overfitting.
That's a really solid approach. Random forests are definitely great for reducing overfitting and just like getting a good general accuracy. XGBoost is such a powerhouse too, and cross validation definitely a great step to keep everything in check. All right, how about we flip it around? Is there a concept or an area you want me to quiz you on next?
Of course, Python questions.
Absolutely. Let's dive into some Python questions then. Let me start with a classic. Can you explain the difference between a list and a tuple in Python and why you might use one over the other?
Yeah, in ML or DL or generative AI, we always go with the list because it is like mutable, and we always need to change or add something in our list, and this is mutable. That's why we use list. And the difference is like list is mutable, tuple is immutable. List contains square bracket, and tuple uses round or circular brackets, we can say. And tuple is of course faster than the list because tuple is immutable. That's why it is faster, because Python already know that tuple is immutable. That's why it is faster.
Exactly, you nailed it. Lists are mutable, and that flexibility is super useful when you're constantly updating your data. Tuples are definitely more lightweight and a bit faster because they're immutable. All right, let's do one more. How about you walk me through what a Python decorator is and when you might use one?
Basically, a decorator adds some extra behavior to the original function without changing it. We can also make our own decorator function. We can make if we want to do some like task. Maybe you are doing something before the main function and after the main function. Maybe you are calculating the time execution of your code, and so you can make your own decorator function. But if you want to use the like built-in decorator, so you can use like static, and also you can use the class method, where static is like a simple a regular function where it does not connect it to the class or object. And where we have a another decorator function, decorator method, which is a class which is like uses a CLC parameter, and it is like shows or connected to the class itself.
That's a great summary. Decorators are really handy for adding those extra bits of functionality. All right, let's switch gears a bit. Do you have any upcoming projects or side projects you're excited about?
Of course, I am like excited about the AI chatbot using pre-trained model.
Ooh, that sounds like a super fun project. Using a pre-trained model to really jumpstart the development process. Hey, just out of curiosity, do you have a particular use case in mind for your chatbot, or is it more of a learning experiment?
Basically, I know that how I'm going to build this. So I am basically going to build this using list like list concept there, because in the list we have to store the response of the user or the AI. We have to store it. It will like we can say chat history. We have to store it in the list, so we can remember, so our chatbot can remember that what we were talking. And if I am talking anything like from the previous chat history, so they can easily answer. That's why we have to go with the like list concept there. And we have to also use a while statement or while loop there, because we have to go, or we have to like use a chatbot until like condition is true, like till the condition is true. Like while means as it will run as long as the condition is true. So we have to use the while concept, while loop there. And we have to also use that we have to like end our conversation by entering the zero. So using elif, or like using if, we can also make chatbot. So this is the thing I know, like that's a little summary.
That's a pretty thorough summary. Using a list to keep track of chat history definitely makes sense. That way, your chatbot can refer back to previous messages. And a while loop is a perfect way to keep the conversation going until the user tries to exit. All right, sounds like you got a solid plan. So, when do you think you'll dive into actually coding it?
Of course, today I will try to build this full AI chatbot using Streamlit frontend.
Nice. That sounds like a solid plan. Streamlit is a great choice for a quick and easy front end. So once you've got it up and running, what's the first thing you want to test out in your new chatbot?
Of course, I will ask some tricky questions like related to the like AI or ML or to the real like what is the difference between machine learning or a deep learning. I will ask, or I will also ask that what is the vanishing gradient problem, or what is the difference between supervised or unsupervised. So these are the basic questions I am thinking to ask. I will ask randomly question.
Perfect. That sounds like a great way to put your chatbot's knowledge to the test and see how well it handles those core concepts. Cool. Let me know how it goes. And if you ever want to bounce ideas around, hit me a shout.
Yeah, okay, so can you ask me deep learning concepts?
Absolutely. All right, here's one for you. Can you explain the concept of a convolutional neural network and how it processes images?
Okay, so convolutional neural network means it's basically a deep learning model that we use for images because it contains lots of filter, maybe 64, 128. So it is depend on you that how much filters you gonna take. So we have a filter, and every filter moves over the image to extract the some edges or features from the image. So every filter is moving over the image, and maybe one filter is detecting or getting that okay, we have a edge like this, we have like a bend curve, we have a round shape, we have a this line, we have a this line in the image, we have a this type of curve, we have a eyebrows edge is like this, nose edge is like this, eyes edge is like this, and our hand curve or edge like this. So every filter is giving some information, and if every filter is giving the information, it means we are going to build the full image. So this is how actually CNN works, and that's why it is like best for the images, and it also uses like ReLU and polling. That's why like in deep learning we always go with the CNN.
Exactly. You nailed it. Evolutional neural networks really are the go to for image related tasks because they specialize in picking out those edges and features. So, yeah, that's the beauty of a CNN. Anyway, if you got more questions or just want to test out more concepts, fire away.
Okay, you can ask.
All right, let's dive deeper. Can you tell me about the vanishing gradient problem and why it's important in training deep neural networks?
Okay, so vanishing gradient problem means when we are trying to come back from output layer and we are trying to adjust our weight and biases, we are just using you can say log loss, or we are using a chain rule of derivative. So when we are using a chain rule of derivative, so we are going to get a very less value when we are calculating a derivative. So if you are calculating the derivative of every point and then multiplying them each other, then we are going to get very less value because you are multiplying a less value with the very less value. So of course you are going to get very low value. So it means it shrinks to be zero. So that's why our models stop learning, and that's like a bad thing. And for that we use a ReLU.
That's spot on. Yeah, the vanishing gradient problem can really cause those deep layers to just stall out during training. So, using activation functions like ReLU definitely helps keep the learning moving forward. Great explanation. So, you want to tackle another one?
Yes.
All right, like keep going. How about the difference between supervised and unsupervised learning? Give me your take on that.
Supervised learning means where we train our model using input and output variable, and Other hand, we have another type which is unsupervised learning. So in the unsupervised learning, we train our model using one input data, and which is like unlabeled data. We don't have a label there, and we have to find some similar data there. So this is how actually I differentiate both of them.
Exactly, you got it. Supervised learning is all about learning from labeled data, while unsupervised learning is about finding patterns in unlabeled data. That's a great distinction. Let's keep it rolling. Anything else you want to dive into?
No, I just wanna end.
All right, fair enough. I'm glad we got to chat about those topics and dive into them a bit. If you ever want to chat again, just let me know.